All right, question number here. Let's plot those points out here. 0, 4, 4, 5. Actually, 0, 4, 4, 5, and 1, 0. Okay. So with that triangle, we want to go through and calculate the sides of those triangles, okay? Unfortunately, we have to go through and use the distance formula for 3 of those. Nothing's just vertical or horizontal, so let's go ahead and do AB. All right, AB, x minus x squared, and y minus y squared. Okay, that gives me 16 plus 1, so we get the square root of 17 is AB. Go through and do the same thing for BC. All right, BC is going to give me, I'm going to shorten this, change in the x's and change in the y's. 25 plus 9 is square root of 34. That does not go down any further. And the other one is AC. Change in x's, change in y's. I get the square root of 17. Okay, because of those 3 side lengths, what we have then is an isosceles triangle. So we're going to then determine if it's acute, right, or obtuse. And to determine that, we're going to see if Pythagorean theorem works. If it doesn't work, if it works, it's a right triangle. If it doesn't work, we're going to see what that relationship is with c squared compared to a squared plus b squared. So right now we get an isosceles. And we're going to take in the longest side, c squared, and see how it compares to a squared plus b squared. Okay, the square root of 34, 34 times 34 is a large number. It's perfect, but the square root of that takes you back to 34. Same thing with 17 and 17. Okay, because of all that, we get equal side lengths, or not equal side lengths, but we get that a squared plus b squared is equal to c squared. So we bring it together. We're going to say it is isosceles since AB is equal to, is congruent to AC, and a right triangle since a squared plus b squared equals c squared. Okay, number 2, graph them out. -4, -2, 2, 4, 2, 4, 8, -2, and 2, -8. Okay. Good old distance formula. I'm going to take side AB and start it off with the distance formula. All right, change in the x's. Okay, 6 squared. Change in the y's. Also 6 squared. Work it out. We get 6 root 2 for AB. BC. Okay, change in the x's. Change in the y's. Work it out, and we get another 6 root 2. So far, 6 root 2, 6 root 2. Okay, when I work out CD, again, I've worked this out before, we get ourselves another 6 root 2. And when I work out the last side, AD, I also get another 6 root 2. So we are down to either a rhombus or a square. Now it's about the slopes. So rise over run, up and over. Okay, so I'm going up from -2 to 4, that's up 6, and I go right 6. Okay, I get a slope of 1. Go calculate me the other rise over run, the adjacent side. I went to the right 6, and I went down 6, and I get a slope of -1. Okay, if I repeat that, I find out that all the sides are either 1 or -1 for a slope. And what that tells me then is we have ourselves a right angle, we have ourselves a square. So it is a square. Since all sides congruent, we showed that. And the adjacent sides are perpendicular due to negative reciprocal slopes. So 1 and -1 are negative reciprocals of one another, and because of that, that means they are intersecting at a right angle.